Welcome back to The Explainer. Today, we are exploring one of the most absolutely crucial breakthroughs in artificial intelligence. Seriously, if you've ever wondered how to get an AI to actually know your business's specific data rather than just taking a wild guess, you are in the exact right place. We're going to demystify a fascinating architecture called Retrieval Augmented Generation, or RAG for short, and we'll see exactly how it makes large language models reliable and secure for real-world enterprise applications.
Okay, let's dive into this roadmap. We'll kick things off with the problem with standard LLMs, then we'll enter Retrieval Augmented Generation. Next, we'll look at how RAG actually works under the hood, compare it against fine-tuning, and finally, we'll explore some real-world RAG applications. Section 1. The problem with standard LLMs and standard AI flaws. To really grasp why RAG is such a game changer, we first have to look at the baseline problem. Standard generative AI models are amazing, right? But they are trained on finite, public data sets with strict knowledge cutoffs. There's this brilliant analogy from AWS that I just love for this. They describe a standard large language model as an over-enthusiastic new employee who refuses to stay informed with current events, but will always answer every question with absolute confidence. Hit the nail on the head, right? That perfectly describes what we call in the industry AI hallucinations. A hallucination happens when an AI detects false patterns and spits out made-up, non-authoritative, or completely outdated information as an absolute, unquestionable fact. In a business context, that kind of confident inaccuracy is a massive liability. So let's break down these specific flaws noted by both AWS and IBM. Because standard models rely purely on their static training data, they're highly prone to hallucinations and are completely boxed in by that dreaded knowledge cutoff date. Plus, they literally cannot provide verifiable source citations. If an AI gives you a number, you have no idea where it got it. AWS also points out a fascinating issue called terminology confusion. Because generic training data uses the exact same words to mean totally different things across different industries, the AI easily gets tripped up. And finally, if you want to teach the AI new facts, well, retraining it from scratch is insanely expensive computationally. Essentially, you're forcing the AI to guess rather than truly know. Which brings us to Section 2. Enter Retrieval Augmented Generation, a new AI architecture. Let's shift gears from the problem space to the solution space and introduce the hero of our tech journey today. So what exactly is RAG? Retrieval Augmented Generation is an AI architecture that essentially connects a generative model to external, authoritative knowledge bases before it generates a response. Think of it like giving that overenthusiastic employee an open book test, but with your company's official, up-to-date manuals. RAG brilliantly bridges the gap between purely generative models, which are super creative but prone to making things up, and purely retrieval-based models, which just fetch documents but can't actually hold a conversation. It grounds the AI in factual reality. When you synthesize the insights from IBM and AWS, RAG's superpowers really become clear. First off, cost-efficient AI scaling. You don't have to retrain your massive foundational model. You just update the database it reads from. Second, it gives the AI access to live, domain-specific data. We're talking internal PDFs, real-time data feeds, current pricing tables, the whole shebang. Third, and this is absolutely huge for building user trust, RAG allows the model to give verifiable source citations. It can tell you, hey, I got this from paragraph 3 of this specific internal document. This drastically lowers the risk of hallucinations and gives developers total control over data security. Section 3. How does RAG actually work? Understanding how RAG works under the hood. Now, what's really interesting about this slide is seeing how this all builds into an actual working system. It happens in 5 distinct stages every single time you ask the AI a question. Stage 1, you, the user, submit a prompt. Stage 2 is retrieval. The system takes your prompt and goes hunting in an external knowledge base for highly relevant data. Stage 3 is integration. It takes your original prompt, packages it together with the cold, hard facts it just found, and creates a brand new augmented prompt. Stage 4 is generation. The large language model reads this augmented prompt and synthesizes a natural conversational answer. And finally, Stage 5 is output. You get a highly accurate answer complete with those verifiable citations. But to make that retrieval step actually work, RAG relies heavily on something called a vector database. As IBM explains it, a vector database takes all your unstructured data, your PDFs, your emails, your policy manuals, and uses a process called embeddings to transform them into mathematical, numerical representations. It maps them in a multidimensional space based on semantic similarity. So when you ask a question, the system is literally using math to instantly find the most contextually similar information. But IBM also notes a vital technical detail here. Developers absolutely must use chunking. You have to break large documents into smaller chunks before turning them into vectors. If the chunks are too big, they overwhelm the LLM's context window. Too small, and they lose their meaning. It is a crucial balancing act.
Section 4. RAG vs. versus fine-tuning, and their training differences. Now, you might be asking a very logical question right now. Why go through all this trouble with vector databases? Why not just take your enterprise data and fine-tune or retrain the AI model itself? Well, let's contrast RAG directly against fine-tuning. Fine-tuning actually retrains the model's internal parameters on your specific data. As IBM points out, this is incredibly resource-intensive and computationally expensive. Plus, once you fine-tune a model, its knowledge is static again. If a policy changes tomorrow, you have to retrain the whole thing. RAG, on the other hand, queries external databases dynamically. It is vastly more cost-effective. If a company policy changes, or you suddenly need to revoke access to a sensitive document, you literally just update or delete the file in your database. The AI instantly adapts without a single drop of retraining.
You also might be thinking, okay, how is this different from just a really good search engine, like semantic search? Simplilearn provides a great distinction here. Semantic search basically just retrieves and hands you an existing document or a relevant text snippet based on your query. It just finds the file. RAG goes a massive step further. It takes that retrieved document, actually reads it, understands the context, and generates brand new, coherent, conversational text to answer your specific question. It doesn't just hand you a manual, it reads the manual for you and gives you the exact answer.
Moving on to Section 5, Real-World RAG Applications and Enterprise Use Cases. And this brilliantly illustrates how leading enterprises are actually deploying this technology right now. Across AWS, IBM, and Simplilearn, we're seeing some incredibly versatile use cases. Companies are building specialized customer support chatbots that actually know the latest up-to-the-minute return policies. In highly regulated fields, they're building financial and medical research tools where accuracy isn't just nice to have. It's a matter of compliance, or even life and death. One of my absolute favorite examples comes from AWS, an HR knowledge engine. Picture an employee typing into a chat, "How much annual leave do I have left?" The RAG system instantly retrieves the company's annual leave policy, cross-references it with that specific employee's past leave record from a secure database, and generates an exact mathematically correct answer in seconds. We're also seeing it used for content generation with automated citations and even highly contextual e-commerce recommendations.
But before you rush off to build your own RAG pipeline, we do need to talk about a critical security warning highlighted by IBM. Because RAG connects directly to your proprietary data, that data absolutely must be protected. If your vector databases are unencrypted and a breach occurs, attackers can actually reverse the embedding process. Yeah, they can turn those mathematical vectors back into plain text and access your most sensitive corporate secrets. So for the IT professionals tuning in, securing those vector databases is absolute paramount priority number one.
Which brings us to our final thought for today's explainer. As you look at all the AI solutions being pitched to your business right now, I want you to ask yourself one provocative question. Is your AI guessing, or is it knowing? Standard LLMs are fantastic for sure, but without external grounding, they're ultimately just guessing the next most likely word. RAG totally changes the paradigm. It grounds your AI in factual reality, giving you the security, the accuracy, and the confidence required to truly transform your enterprise. So, what does this all mean for the future of your tech stack? Thank you so much for joining me on this deep dive, and keep learning.